Hello students, welcome to my channel ChemQuest. My name is Anam and today you will come to know about the states of matter. But before starting our main topic, let's talk about the quotation of the day. So it says that be proud of yourself because only you know about your struggles. Only you know how many times you have rebuilt yourself to achieve your goals. I think so you have get motivated and then start the topic. So let's talk about the arrangement of the particles in case of solids, liquid, and gases. So you can see the particles are so much closely packed together. While in case of liquids, they are not closely packed, but they can move from one place to another and they have not at their fixed positions. While in case of gases, the particles are so much spaced apart and they can move from one place to another in a very random way. Now let's talk about some of the properties of the solids, liquids, and gases. So now let's talk about the shape and volume of the solids, liquids, and gases. So in case of solids, in case of liquid, in case of gases. So solids have fixed shape and fixed volume, but liquids do not have fixed shape but it has fixed volume. And gases do not have fixed shape and volume. If I talk about the rigidity, solids are highly rigid while liquids are less rigid and gases are negligible. Now let's talk about the intermolecular forces. So in solids, there are very much strong intermolecular forces. So you can say the strongest intermolecular forces are present in solids. Then in liquids, there are lesser. And in case of the gases, there are weakest intermolecular forces of attractions. Now, if we talk about the compressibility, as you know, the particles are so much closely packed together in case of solids, so therefore they cannot be compressed. So there is no chance of compressibility in case of solids, and in case of liquids, there is slight possibility of the compressibility. While in case of the gases, they are highly compressible. They are highly compressible when the pressure is applied on it. Now let's talk about the density. So obviously in solids the particles are so much closely packed together, therefore their density is high. Air low density in case of liquids and very low density in case of gases. Now diffusibility. Diffusibility means mixing up of the molecules. So obviously, again, the same reason the particles are so much closely packed and they cannot move from one place to another in case of solids. So therefore, they cannot diffuse. Okay, and the liquids obviously they are less diffusible, but gases are very highly diffusible, and you can. If we talk about the kinetic energy, obviously solids have the least kinetic energy. Why? Because the particles cannot move from one place to another. They are fixed together. The reason is that they do not have enough energy to overcome the intermolecular forces and to move from one place to another. Or in case of the liquids, obviously the particles have some amount of the kinetic energy, therefore they can move from one place to another. So therefore, their kinetic energy is intermediate, and gases, they are highly movable particles. They move from one place to another in a very random way. Therefore, they have a very high kinetic energy. So these are some properties of the states of the matter. So let's talk about the phase changes. This is the solid, and when it converts into the liquid form, this process is called melting. And let's suppose this is the example of the water. So I'm taking the example of water and we will talk about its phase changes, okay? So, in case of solid, the particles are so much tightly packed, but when it is melted, how it is melted? Obviously, you will provide some amount of energy in form of heat, you will heat it, and the particles will gain energy and they will gain enough energy to break the intermolecular forces between them and they can be spaced apart. So this process is called melting and it converts into the liquid state. And when you again heat it, when you again heat it, the particles can gain more and more energy, and the particles just break intermolecular forces that are present in the liquid form, and they will just convert into the gaseous state. You know, the particles are so much spaced apart, they have negligible intermolecular force of attractions, and they just move more quickly than that of the particles of liquids. Now, this process of conversion of liquid into gas is called evaporation or boiling. And so the difference between the evaporation and boiling is that boiling takes place at a specific temperature. Let's say that there is 100 degrees centigrade boiling point of water, or let's suppose the boiling point of the ethanol is 78 degrees centigrade. So different liquids have different boiling points. So there's the fixed temperature at which the vapor pressure of the liquid becomes equal to the external pressure. But in case of evaporation, evaporation can take place at any temperature. Let's say you have put some water in the glass, or the evaporation of the liquid of the particles of the liquids in the lakes and rivers, and they just move up into the atmosphere and they form the clouds. So this process is called evaporation. It takes place at any temperature. It's not necessary that it should be 100 degrees centigrade for the conversion of the liquid into the gaseous state. Then, so the conversion of the liquid into the gas is either evaporation or the boiling. Now, let's reverse these processes. If I say that the conversion of the gas into the liquid is called condensation. So condensation is a process by which the gas or vapor changes into the liquids when it is cooled to its dew point or comes into contact with the cooler surface. So this process occurs due to the loss of the thermal energy, which reduces the kinetic energy of the gas particles, allowing them to come together and they form the liquid droplets. Now, let's talk about the freezing. So obviously, when the liquid is converted into the solid, this process is called freezing. And again, the energy between the particles is decreased, and there are more intermolecular forces developed in the particles of the solid. So these are the four processes. Now let's talk about the energy changes that are associated with the phase change. So in the first step, this was melting. So melting is endothermic. Why it is endothermic? Because you have to provide energy to the particles of solid so that the intermolecular forces between the particles just break down and they convert into the liquid state. Now, boiling and evaporation. So you have seen in the previous slide that you have to provide the temperature to the particles of the liquid so that it can be converted into the gaseous state. And again, you have to provide the energy so that the intermolecular forces between the particles of the liquid just break down and they convert into the gaseous state. So, condensation. Condensation is exothermic because you are decreasing the temperature of the particles. So, the extra heat or energy is just going into the atmosphere. So, the process in which the energy is released from the reaction or from the mixture. So, this process is called exothermic process. And in case of the freezing, again, liquid is converting into the solid and you are decreasing the energy of the particles. So it means that extra energy is just releasing into the atmosphere so that this process is. So let's talk about this heating curve. So as you can see, when you provide the heat, okay, so heat is added. So in the forward, when you are converting, you are melting and you are boiling, this process is endothermic process. Okay. So let's suppose this is minus 40 degrees centigrade temperature and you're increasing the heat, you are adding the heat. So therefore it reaches this point. This is 0 degree centigrade temperature. Okay. And at this point, this process is called melting point. Why? Because here liquid and solid, they are in equilibrium. Like there will be some solid particles and there will be some liquid. As you know, when you melt the ice, so when you heat it or when you place it at the room temperature, you will just see that this does not instantly convert into the liquid. Obviously, some of the liquid will be there and some of the solid will be there, and the process takes some time to completely convert into the liquid state. So that point is actually liquid solid equilibrium, and this point is called melting point. At that point, the temperature remains constant. And when at when all the solid is converted into the liquid, then what happens? Adding heat increase the further temperature and it converts into the liquid. Now, this is the liquid phase. Now, when temperature reaches and temperature going on increasing, 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 and the point reaches when the temperature is 100 degrees centigrade. So at this point, when temperature reaches 100 degrees centigrade, this is called the boiling point of the water. And at this point, again, all the liquid does not convert into the gas instantly, but of course, it takes some time to completely convert into the gaseous state. So this process at which this temperature or this time at which the gas and liquid are at equilibrium, this is called the boiling point. And then when all the liquid is converted into gas, so this is the temperature again increases, again rises. Now you will see a difference that the time taken for completely conversion of the solid into the liquid is lesser. Okay, while it takes more heat. So heat taken for the conversion of solid into liquid is lesser, while heat taken for the conversion of the liquid into gas is greater. Why it is so? Because when you convert the solid into the liquid, you will see the particles are still closer together and there are some intermolecular forces of attraction between them. Just you break some of the intermolecular forces so they can move apart. Okay, but when you convert liquid into the gas, the particles have negligible intermolecular force of attractions between them. So you have to give a lot of heat to break all the intermolecular forces so that the particles become so much spaced apart that they do not have any intermolecular force of attractions. And the particles of the gases are even more and more random than that of liquid. So yeah, so that you have to provide more and more heat to convert the liquid into the gas. So it takes more heat for the conversion of gas into the liquid. So this is the heating curve. So this was all about the three states of matter. Thanks for watching my video. Don't forget to subscribe and press the bell icon. Thanks.